Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the tetraamine copper complex, and now in this topic we are going to talk about the structure of hexaamine cobalt complex. So what is the structure based on the VBT? Let us find it out in this topic. So friends, in this case we have to talk about the structure of the coordination compound, and in this case I'm talking about this ion. So the ion is nothing but that is hexaamine cobalt ion on basis of VBT. So in that case we understand that is the cobalt is the one which is the central metal atom. So for that we should understand that is the cobalt has an electronic configuration that could be written as argon 18 4s2 3d7, or else I could write that is 3d7 4s2, and then again I would write that is 4p0. So in this case, suppose if I talk about the 3d orbital, so suppose if I'm talking about 3d orbital, then I'm talking about 4s, then let's talk about 4p. So in that case we understand that is the 3d orbital, obviously it is a subshell which consists of 5 orbitals, 1 2 3 4 5 orbitals. This s consists of only 1, while this p consists of 3. So this 3d has basically 7 electrons, and this is what we are going to talk about, that is cobalt in an atomic state. But the thing is we have to calculate the electronic configuration of the cobalt 3+ ion also. The reason behind that is because if we talk about the oxidation state of this cobalt, so if we do the calculation, so that in that case we'll get to know that is the NH3 is nothing but a neutral ligand. So therefore the cobalt has an oxidation state of 3+. So therefore I'm going to talk about the electronic configuration for cobalt 3+ ion, and so this is what I could get, that is argon 18 3d 4s 4p, where there are 3 electrons that are being lost. So therefore the electrons would be lost from the s orbital, and 1 electron it will be lost from the d orbital. So therefore only 6 electrons that would be left in the 3d orbital. So therefore I could fill the electrons in this way, that is 1 2 3 4 5, and this is the 6th one. And talking about s orbital, obviously there is no electron in the s orbital and there is no electron in the p orbital. So therefore this is what we have. But the thing is, we are talking about the ligand, and that ligand is nothing but NH3. So NH3 is known to be a strong field ligand. That's the reason that because of which even there are unpaired electrons, as you can see over here. So this unpaired electron will undergo through spin pairing, and that is how basically the pairing will occur whenever the NH3 is approaching the central metal atom, and in that case it is cobalt. So in that case, whenever the NH3 is approaching the central metal atom, so because of the spin pairing, this electrons will get paired up, and that's the reason that we could get a particular hybridization of the central metal atom. And the central metal atom will hybridize in such a way that is we could get a particular geometry. So what would be the geometry and how does the pairing occur? So let me talk about that here itself. So suppose if I'm talking about the pairing of electrons, so in that case there are 5 orbitals, as you can see over here. There is no electron in the 4s orbital, and there is no electron in the p orbital also. But because the NH3 is approaching, so obviously there will be pairing over here. So therefore we could find that is these 2 are already paired. So this 4 electrons it will get paired up, thereby leaving 2 vacant orbitals in the d, that is d subshell, and it was already vacant, and even this is already vacant. But now let us understand that what would be the hybridization of the central metal atom in this case. We understand that is there is 6 ligands or 6 NH3 groups that are been approaching the central metal atom cobalt. So for that we need 6 empty orbitals, and in that case we have 1 2 3 4 5 and 6 orbitals here. So that means what we have is we have 2 d orbitals, we have 1 s orbital, and we have 3 p orbitals. So in that case the cobalt will undergo through an hybridization, and the hybridization is d2sp3, or we could also call it as sp3d2. So this hybridization of the cobalt 3+ ion will give the structure to the molecule and the molecule will have a structure that is octahedral structure. So based on that, let me give you a certain example, that is what would be the structure of it, but let us understand that is how many electrons it would be donated by the overall ligand. We understand that is the ligands, they donate a lone pair of electrons. So in that case, suppose if I'm talking about the NH3, so the NH3 will have one NH3 can donate, that is one lone pair, that is 2 electrons. So this is one NH3, this is the second one, third, fourth, fifth, and 6th. So an overall of basically 12 electrons are being donated by the ligand itself to the central metal atom, that is cobalt, or I could say central metal ion, cobalt. So this is what we have, and the structure and the hybridization, that is what we have got. And now let us draw the structure of it. So in this case, we could get that is cobalt, that will be in the center. It will be surrounded by 4 NH3 ligands that are on the plane, while the rest of the 2, they will be here. One will be above the plane and one will be below the plane, making the geometry which is known as octahedral. So therefore this is what we have. So that's it. And now let me talk about the magnetism. Obviously we have find it out that is there is no unpaired electron, and that's the reason this kind of molecules are basically known as diamagnetic. And that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope you have got to know about the structure behind this cobalt complex. I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.